A Charizard breathes a jet of fire hot enough to turn sand into glass, and it carries a living flame burning at the very tip of its tail, a flame that, in the games, never goes out. Picture it, 2.5 meters of orange-scaled reptile, wings flare, torching everything in front of it. Biologically, that should be impossible. Reptiles don't make fire. Their bodies are wet, they run cold, and the last thing natural selection wants is an open flame pressed up against flammable tissue. And yet there is a beetle alive right now, today, that sprays a boiling, caustic chemical jet out of its own body at over 100 degrees Celsius. No spark, no lighter, just chemistry. That beetle is the bombardier beetle, genus Brachynes, and it is the single most important animal in this entire video. Inside its abdomen sit 2 sealed chambers. One holds hydrogen peroxide, the other holds a fuel called hydroquinone. Kept apart, nothing happens. But flood them together over a bed of catalase and peroxidase enzymes, and you trigger a violent exothermic reaction that flash heats the fluid to its boiling point and fires it out under pressure, in machine gun pulses, aimed with a swiveling tip. Evolution already built a creature that detonates a chemical explosion inside its own body, hundreds of times a second, without cooking itself to death. So the real question was never, can a living thing make fire? Nature settled that one 100 million years ago. The question is whether evolution could take that trick, scale it up, bolt it onto a flying reptile the size of a grizzly bear, and have the whole machine survive contact with reality. That is exactly the kind of impossible evolved Codex exists to decode. And here's the thing, we treat dragons as pure fantasy, but evolution is full of monsters we wrote off too soon. The coelacanth, Latimeria chalumnae, was assumed extinct for 66 million years until a live one turned up in a South African fishing net in 1938. A lineage that ancient, hiding in plain sight the entire time. So I'm not going to ask whether a fire-breathing dragon could appear out of nowhere. I'm going to treat it as a relic, an ancient reptile line that quietly survived, and ask what 50 million years of real evolution would have carved it into. So here's the plan. I'm going to take Charizard apart and rebuild it as a real animal. Fire, wings, fuel, and all. And score it across 4 make-or-break biological systems, out of 10 each. And stick around, because once we've scored this thing, I'll show you the 3 ways evolution could actually turn it into something far worse. But I'll tell you now, up front, the fire is the easy part. The thing that truly breaks a fire-breathing dragon isn't the flame, it's the wings. Hold on to that. Let's start exactly where it matters most, the thing every single one of you clicked this video for, the fire. Here's how I'm judging it. Any biological flamethrower has to solve 3 problems, and I'm scoring it on all 3. 1. Fuel. You need something combustible your body can manufacture on demand. 2. Ignition. You need to set that fuel alight without a match. 3. Containment. You have to do all of this without converting your own skull into a furnace. Solve all 3 and you've got a genuine fire weapon. Miss one and you've got a very dead lizard. Let's build it. Fuel first. Our dragon won't store gasoline, but it doesn't need to. Methane is flammable, energy dense, and biology already mass produces it. The methanogen microbes living in a cow's gut churn out enormous volumes of it every single day. There's even a bird, the hoatzin, that ferments its food in a foregut like a tiny cow with feathers. So give our dragon a dedicated fermentation chamber and a gas bladder, and it can brew a steady supply of methane, and a lighter, more explosive cousin, hydrogen, and hold it under pressure, ready to fire. Ignition is where the bombardier beetle pays off. We borrow its exact playbook. A small reaction chamber, sitting just behind the throat, holds our hydrogen peroxide and our enzyme catalyst. When the dragon clenches down, peroxide floods the catalyst. The reaction flashes to a few hundred degrees, and that burst of heat becomes the pilot light, igniting the methane hydrogen jet as it rushes out over the tongue. No spark organ, no flint, just 2 streams meeting at the exit, the way a blowtorch mixes gas and air. The flame happens outside the mouth, in open air, which solves half of our third problem before we even get to it. Because containment is the killer. This is what actually murders most fictional fire breathers. They'd incinerate themselves on the first breath. Our dragon survives it the same way the bombardier survives its own explosion, with a reaction chamber lined in tough, heat-resistant, mineral-hardened tissue, a refractory throat almost ceramic in structure, and a hard palate that channels the flame up and out, away from soft tissue. The fire never touches anything that matters. It's pointed, like every weapon worth having. So, does it work? The chemistry is real. The precedent is alive and crawling around your garden. But it is metabolically brutal and one cracked chamber from a fatal accident. Solid, not flawless. I'm scoring Charizard's fire, a predation rating of 7 out of 10. That 7 looks good on the board. It will not survive what comes next. Because everything we just built, the bladder, the chambers, the armored throat, is heavy. And heavy is the one thing a flying animal can never, ever afford. Which brings us to the wings, and to the law of physics, that quietly destroys almost every giant flying monster ever drawn. It's called the square-cube law. When you scale an animal up, its surface area, including its wings, grows by the square of the change, but its mass grows by the cube. Double the size and your wings get 4 times bigger while your body gets 8 times heavier. Wing area loses the race every time. The bigger you get, the harder it is to leave the ground. We do have a real benchmark for how far evolution can push this. Quetzalcoatlus northropi, an Ashdarkid pterosaur, had a wingspan of around 10 to 11 meters, the size of a small plane. And it is the absolute largest animal we know of that ever achieved powered flight. But here's the trick that let it happen. It was almost unbelievably light for its size. Its bones were hollow, pneumatized, threaded through with air sacs, shaving weight everywhere physics would allow. The largest flyer in Earth's history was built like a paper kite stretched over drinking straws. Now look at Charizard as drawn. A thick, muscular, bipedal body, a long tail, stubby wings that, frankly, look far too small for that frame. And we've just loaded it with a fuel bladder and an armored fire chamber. As pictured, this animal is dramatically too dense, with far too little wing, to ever get airborne. The fan art proportions simply do not fly. To make it work, evolution has to be ruthless. It hollows out the bones. It strips away the heavy muscle and the thick armor plating. It shrinks the body toward the size of a large eagle, not a bear. And painfully, it shrinks the fire organ, because every gram of fuel tank is a gram the wings have to lift. A real flying dragon could exist, but it would be lean, light, bird-boned, and far smaller than the icon. On flight feasibility, I'm scoring it a habitat and locomotion rating of 4 out of 10. The sky is possible. It just charges a punishing toll. And something has to pay that toll. It turns out the bill comes due as a single number. The one number that decides whether this animal is a living predator or a starving corpse. Here it is. To fly under its own power and brew explosive gas around the clock, our dragon can't run cold like a normal reptile. It has to be warm-blooded, an endotherm with a furnace of a metabolism. And warm blood is expensive. A hummingbird, gram for gram, burns energy at a rate that would require a human to eat their own body weight in food every day just to stay alive. Scale that hunger up to an active flying predator, and the appetite becomes the defining fact of its entire life. Run the rough math, and our eagle-sized fire dragon needs to take down the equivalent of several large prey animals every week, minimum. And that's before it spends a single breath on fire. Every flame it throws is calories set on fire, literally. Which means our dragon cannot be the trigger-happy show-off from the cartoons. In the real world, it would be a careful, frugal hunter that hoards its fire for the moments that genuinely pay off, finishing a kill, winning a territory fight, escaping something bigger. Fire is the most expensive tool it owns, so it would use it like the most expensive tool it owns. And here's the part the game's quietly got right. Pokemon players know the rule. If the flame on a Charmander's tail ever goes out, it dies. For years, that's just been game logic, but turns out it's surprisingly good biology. For an animal whose entire survival depends on a working fire organ, a small, always lit pilot flame really would function as a life support system, a permanent ignition source that never has to be restruck. The games accidentally built a real piece of physiology. That trickle of fuel to keep the tail lit, though, is one more constant drain on an already crushing energy budget. So on diet and fuel economy, the demands are enormous and the margin for error is thin. I'm scoring it a dietary rating of 5 out of 10. There's one system left, and it's the one nobody thinks about. Because before any of this can hunt, it has to grow up. And a baby that hatches with a sack of explosive gas in its throat is a genuine problem. A reptile this size almost certainly lays eggs, rather than giving live birth large clutches buried in warm ground, maybe even incubated by geothermal heat instead of body heat, the way some reptiles already nest near volcanic soil today. But the real puzzle is the fire organ itself. You cannot hand a clumsy, uncoordinated hatchling a fully loaded chemical weapon. It would gas or burn itself in a week. So evolution does what it always does with dangerous adult equipment. It delays it. The fuel chambers and the ignition gland would mature late, switching on only as the animal approaches adulthood. The same way antlers, tusks, and other risky adult hardware develop on a timer, long after birth. The juvenile starts with nothing but that faint pilot flame, a warm ember, not a weapon, and earns its fire as it grows into the body that can survive it. The cost of all this is time. Large, slow-maturing apex animals reproduce slowly. A Komodo dragon, our best living model for a giant predatory reptile, takes around 5 years just to reach maturity and can even reproduce without a mate through parthenogenesis when one isn't available. Slow breeding makes a species powerful but fragile, hard to wipe out one by one, but devastating to lose in numbers because the population rebuilds at a crawl. A workable strategy with a real Achilles heel. I'm scoring it a reproductive rating of 6 out of 10. So add it all up, and on paper, our dragon barely works. Lean, hungry, careful, slow to breed. But evolution doesn't deal in barely. Give this animal 10 million years and a continent to spread across, and it doesn't stay one creature. It splits into 3, and one of them is an absolute nightmare. Let me give our real-world dragon a name first. Pyrodraco volans. The genus combines pyro, fire, and draco. Dragon, the flying fire dragon. From this single founding species, here are the 3 ways evolution could take it. Branch 1. The cooperative path, the firekeeper. On this branch, Pyrodraco learns that fire is more valuable as a tool than as a weapon. And this isn't fantasy, it happens on Earth right now. A 2017 study documented something extraordinary in northern Australia. Birds of prey, black kites, and brown falcons deliberately picking up smoldering sticks from wildfires and dropping them into dry grass elsewhere, spreading the blaze to flush out fleeing prey. Indigenous communities had described these firehawks for generations. So picture Pyrodraco perfecting that strategy with an organ that makes fire on demand, a keystone species that sets controlled burns across grasslands, driving prey into the open, recycling dead brush, and resetting the whole ecosystem on its own schedule. Not a monster, a landscape gardener that breathes fire, genuinely beautiful and genuinely terrifying to live next to. Branch 2, the specialist path, the grounded ember. Here, evolution looks at that brutal flight toll from earlier and simply refuses to pay it. Pyrodraco gives up the sky entirely. Freed from the weight limit, it can pack on heavy mineral armor and grow large again. And it settles down right on top of its fuel source, volcanic, geothermal terrain. It basks in vent heat to slash its own metabolic costs. Mines, sulfur, and mineral catalysts straight from the rock to feed its fire chemistry, and rules the ash fields as a heavily armored, flightless, slow-burning tank, a Komodo dragon crossed with a volcano. It traded the wings for a fortress, and on its own ground, almost nothing can touch it. Branch 3, the aggressive path, the firestorm. This is the nightmare. On this branch, evolution doubles down on the weapon and solves the calorie problem in the most horrifying way possible by using the fire to feed the fire. Pyrodraco evolves a superheated jet, hot enough not just to kill, but to pre-cook its prey on the spot. And cooked meat is the key. Cooking unlocks far more usable energy from the same carcass than raw flesh ever could. So the very weapon that burns calories starts paying them back. The result is an aerial apex predator that strafes a herd, ignites the grass to trap it, and dines on the roasted survivors, turning fuel cost into fuel profit. This is the dragon that doesn't just live in the ecosystem. It runs it from the air, on fire. That's the version that ends up in the legends. So let's close the codex on this one. Fire, a 7. Flight, a 4. Fuel, a 5. Lineage, a 6. That averages out to a 5.5 out of 10, and that number tells the real story. A fire-breathing dragon is genuinely, scientifically plausible. The chemistry exists, the flight is possible, the biology holds together, but it would not look like Charizard. The real thing would be smaller, lighter, hollow-boned, with a modest flame and a monstrous appetite closer to a fire-spitting eagle than a bipedal bruiser. The icon survives not as a portrait, but as a principle, a relic lineage that could have been hiding in plain sight the whole time, the way the coelacanth fooled us for 66 million years. And honestly, a lean, ravenous, fire-keeping raptor might be even more unsettling than the cartoon. If this rewired how you see Charizard, hit subscribe. One creature decoded every week. Until next time, stay curious, and I'll see you all in the next video.